All right, our final task is learning how to draw graphs using limits. Yes, it'll be interesting to see if I can make an actual activity for you. Hopefully it'll happen. But you can learn about it. So what we do is we go through the whole list, and then we're going to use these requirements to create a graph. So we first say the limit as x approaches 1 is 3. So if it's at 1, that means from the left and from the right, it's got to be hitting 3. So when x is 1 at 3, I'm always going to put an open circle for a limit, just in case, because I'm not sure yet if it's closed or open. And it's left and right. So frequently I draw like a dash out to the left and a dash out to the right so that I know I'm connecting from both sides. The next one says as x approaches 3 from the right, y is negative 2. So I've got x is 3, and then y is negative 2. I'm going to do an open circle again, and it said from the right. So I'm going to draw a dash out to the right, so that at the end when I create my graph, I know which direction to go. And then when x approaches 3 from the left, I'm going to be hitting positive 2. So I'm going to go up to positive 2, put an open circle. Now I know it's from the left, so I'm going to put a dash out. So there's a good chance that those two dashes are going to connect to each other. So I may have to erase them a little bit later to make them smoother, but that's a good bet. Then we know is x, and when f of 3 equals 1. So that means x is 3 and y is 1. So this is like the coordinate point 3, 1. And since the function equals 1 there, that means it's going to be a solid dot. So I'm going to go to the point 3, 1 and put a solid dot. So that means it's a good thing we did an open dot here and an open dot here, because otherwise the function would not have passed the vertical line test and it would no longer be a function. Because you can't have two solid dots on top of each other. Then we've got as x goes to negative 2, where our y value is negative 1. And once again, this doesn't say left or right, so that means both. So x is negative 2, y is negative 1. I'm going to do an open dot. And then since it's left and right, I'm going to do dashes to the left and to the right. And finally, f of negative 2 is undefined. So that means when x is negative 2, there shouldn't be a solid dot anywhere. So it's a good thing we did an open dot here, because otherwise it wouldn't be undefined. So our final step is just connecting everything together. So I know that I've got a dash here and a dash here, so I can just connect those two together. These two dashes, I'm going to erase it a little bit just so that it stays a function. So this dot and this dot both had dashes, so they are going to connect. And then this dash is going off to the right, and it's just going to go on forever. Doesn't matter where you draw it, as long as it stays a function, so don't make it like into a curly Q. Same thing with this going to the left, so it can just go wherever you want to the left, as long as it's still a function. Let's try one more. So for this graph, something new, we see DNE. So DNE means the function does not exist there. So there's a good chance that this is going to be an asymptote. Oh, the reason I know it's an asymptote is because of these infinities. So if it's saying negative infinity or positive infinity, we know with the does not exist, there's going to be an asymptote. So as x approaches 0 from the right, it's not going to exist and it's going to go to negative infinity. So what that tells me is at x is 0, I'm going to have an asymptote. So I'm going to draw an asymptote along here. And because our function, it's saying as x approaches 0 from the right, it goes to negative infinity, I'm just going to go, as I'm approaching this from the right, I'm going to draw an arrow going down to negative infinity to remind, oh, that's pretty bad, to remind myself that it's going down forever. Then as x approaches 0 from the left, I'm going to be going up to positive infinity. So if I'm approaching it from this side, it's going to go up forever. So I'm just going to draw myself an arrow up so that I know that eventually I'll have that. Then it's saying f of 5 equals negative 2. So at the point 5, negative 2, I'm going to have a solid dot. And then as x approaches 5, our y value is 6. So at x is 5, we're going to go up to 6. And because we already have a solid dot, we know for sure this is an open dot. And since it just said 5, we know it's left and right. So I'm going to draw little dashes to both sides. And then finally, the limit as x approaches negative 6 also does not exist. So I'm going to have another asymptote at negative 6. And it says going to positive infinity. So as I'm approaching negative 6, and since it doesn't say left or right, it means both. So both on the left and the right, it's going to go to positive infinity. So when I'm drawing, I've now accounted for all of these different parts. So as I draw my graph, I've got to just connect all my parts. So I'm going up on this side and up on this side. So I bet that's going to make a parabola-like shape. So I'm just going to kind of draw it like this. On this side, you can choose however you want to draw it as long as it's a function. So I'm just going to draw it off like this. Here we have an arrow going off to the left, and what I can see to connect it to is this arrow. So we know it's got to go to negative infinity for forever. So I'm going to try to connect those two together. This dot doesn't say left or right, so it's just going to stay a dot, and then this side is going to go off forever. So make sure when you're drawing you don't overlap lines, because then it's not going to be a function anymore. So hopefully I've been able to create a practice for you, so see if you can draw some graphs.